Rocks. The hardest topic we're going to talk about all year. It's tough to imagine, but New Jersey, we have all different kinds of rocks. From igneous rocks that come from volcanoes. Who knew? In New Jersey. We've got sedimentary rocks. And we also have metamorphic rocks. We're going to be learning all about these three different kinds of rocks in the state of New Jersey and elsewhere in the world. So sit back and relax as we learn about the fact that every rock has a story to tell.
Welcome to the Delaware Water Gap National Recreation Area, Mount Tammany Geology Hike video podcast series.
As you round the bend in the trail, you will be struck by the large bedrock outcropping you have to scramble over. As you do so, notice the color and texture of these huge rocks that you are climbing over. It's called the spine of the Bloomsburg Red Bed Formation. Here are some examples of the rocks that you'll see along this stretch. These rocks vary in color from kind of a greenish gray to a red the closer you get to the first overlook. They also vary from sandstone to siltstone to shale as you travel in that direction. Each rock tells a story of how it was formed and how it got to be where it is today. The color of the rocks tells you a story of chemistry. As you get closer to the overlook, the rocks get progressively redder in color. That color is a clue that the chemistry is changing as well. In fact, the redder the rock, the more iron it contains. For the same reason Mars is called the red planet, due to the iron oxide rocks on its surface, the red beds here contain a similar chemistry. The texture of the rocks tells you another story. The progression from sandstone to siltstone to shale indicates a change in the size of the particles that make up the rocks. Sandstone is made up of the largest particles, and shale the smallest. So what story does that tell? Well, larger particles found in sedimentary rocks are generally the result of forming in faster moving water, while smaller particles can only settle out of much slower moving water. Essentially, this tells you the story of the conditions during which these rocks were formed. Think about these things as you get closer to the overlook.
I'm at the top here of Meral Creek Reservoir's main dam. This main dam, as you can see, is made out of a lot of rocks. It's technically called an earthen dam. It's not a concrete structure like the Hoover Dam, but earth and rock were put here to prevent the water from flowing out of it. And if you look over to the left, you can see that this rock pile of the main dam is over 200 feet deep. Not many people get to see this particular site, but we're at the base of the main dam. If you look behind me, you can see almost 300 feet of rocks, and the type of rocks were very important in building this particular dam. I want to show you how the dam was built. In order for the dam not to leak, they had to excavate all the way down to bare bedrock. And to do that, they had to blast through all of the rock over top of the bedrock. This particular formation here, you can see all these vertical grooves on the rocks. This is where they actually drilled down into the rocks and put explosives to completely blast away all of the rock on top of the bedrock. If they didn't do that and get down to the solid bedrock, the dam would leak. And that would be a bad thing for all of people living downstream of the dam. I'm paddling now along one of the last free-flowing rivers in the eastern United States. I'm paddling on the Delaware River, up north or upstream of the Delaware Water Gap. Now it's free-flowing because there is no major dam across the Delaware River blocking its flow. And it's unusual that a major river in this country doesn't have a dam across it blocking its flow for either water source or hydroelectric power. The reason for this goes back into our state's history. In 1955, there were a couple of hurricanes, Agnes and Diane, that came up along the coast of our country and hit this region dramatically. They caused incredible floods. And at that time, the Army Corps of Engineers was interested in damming the Delaware River in order to control its flow. Through a series of investigations through the geology of this region, they performed a number of tests, including taking rock core samples from either side of the river valley here near the infamous Tox Island. The project was to be called the Tox Island Dam. Well, from the geologic investigation, examining these rock cores, which they removed from the hillsides, examining the rock structure, they investigated and discovered that the dam, if they were to have built it, would have leaked, and it would have leaked terribly. So over a series of decades, this whole area was preserved, initially to create Tox Island Dam, but now are preserved as about 70,000 acres of the Delaware Water Gap National Recreation Area. And you too can come up here and enjoy a nice peaceful paddle along the Delaware River, because there is no dam here. Had there been a dam constructed, this whole valley would have been flooded, creating a lake about 35 miles long all the way up to Port Jervis at the border of New York, Pennsylvania, and New Jersey. But in my opinion, thankfully, it failed the rock test, the geologic core samples that they took, and as a result, you can enjoy this river and this valley much as the native people did thousands of years ago.